Hello physics students, video 2 this week. We have learned a little bit about how to identify atoms by the light that they scatter. We're going to look at a similar example so that we continue to learn about how we can identify atoms in things very far away, like in stars. Now, for our physics objective, it says I can identify atoms by the light they absorb and scatter. You already did this from the activity. You already identified atoms by the light they scatter. We're going to add on just a little bit by looking at absorb. Absorb. Okay. Now, for our what do you think, we have another do you remember. It says, what color do you see if no light enters your eyes? And maybe color is not the best word, but what do you see if no light, zero light enters your eyes? We talked about it. Take a guess. Here's a good start to your sentence. Remember, I want one full sentence. If no light enters your eyes, you see or I see, what do you see? Write down your answer. We'll remember that in a moment. We did this activity. When we give atoms energy, they scatter. They scatter light. And different atoms scatter different types of light. And you use these like fingerprints to identify certain atoms. This is what scientists do when they want to study what atoms are in an object, especially if that object is really far away. I can't bring the sun into my classroom to look at it. The sun is way out there. But I can use the light to see what fingerprints are there to find out what it is made of. Now, let's look at an example. This is similar to what we saw before in the last video. Here I have light, and there I have light. It's like the rainbow. And I have an atom. And like before, if you watch here, you're going to see the atom absorb and then scatter. Absorb and then scatter. It's very similar. So let's watch. Here's the atom. Look at this. 1, 2, 3, 4, 5 types of light. And then something gets absorbed. Ooh, what got absorbed? Oh, there we see scattering. What light got scattered? It was orange. Let's watch again. Let's watch the orange light get absorbed and then scattered. Let's watch. Okay, here we go. Here comes the light. Here's orange. Orange is going to get absorbed. Look. No more orange. And then it's going to get scattered. Absorbed, scattered. This is what atoms do. They absorb and they scatter. And this atom, remember, like fingerprints, this atom absorbs orange light. Okay, at least in this animation, it absorbs orange and then it scatters orange. Oh, absorbs and then scatters. Mr. Thrasher froze the image. Okay, this is what we looked at in the last video. We looked at the light that's being scattered. Remember how we had like the different lines of color? This is what we looked at. We were seeing the light that got scattered. But we could also look over here. This is the light that did not get absorbed. Because remember, what color got absorbed? Orange. Orange light was absorbed and then scattered. The other colors, they just passed right by. So if our eyes were right here, if we were going like this, we would see red, we would see yellow, we would see green, we would see blue. Would we see orange? No, look, it's missing. It's gone. Okay. Let's think about some of this in detail. We have learned that if atoms gain energy, okay, if they're given energy, they scatter light. They scatter light waves. Remember, absorb, scatter. The opposite is true. And this process is kind of happening at the same time. If that light wave hits the atom, it gets absorbed. Again, let's look right here. The orange light was absorbed. If light is absorbed, my video is blocking the word. It says we do not see it. If light is absorbed, we do not see it. Oh, look at that. Aha! We do not see it. Oh, okay. Does that make sense? Remember, this is your what do you think? What do you see if no light enters your eyes? You see the color black, or you see black. You see white when all the colors, if there's less and less, menos y menos, there's less and less light, it's black. So if you don't see light, if light does not enter your eyes, it is more black. Oh, okay. Let's do a little more learning. You're not writing this down, but let's go through this carefully. Different atoms absorb different types of light. It's like fingerprints. In fact, the light an atom absorbs is the same as the light it creates. It scatters. Remember, absorb, scatter, absorb, scatter. It's the same light. For example, hydrogen creates, it scatters red light if it is given energy. Hydrogen also absorbs. It's absorb, scatter, absorb, scatter. It's the same type of light. So here's a picture. Here's one type of atom, hydrogen. Okay, this is what we saw in our last video, our last activity. This is the light that's being scattered. Sometimes you see the word emission. We're not really going to use that word. Let's use the word scatter. It's kind of easy. Hydrogen scatters these types of light. Purple, blue, kind of a light blue and red. And remember, it's absorb, scatter. It's absorbing the same color. So sometimes if you look at hydrogen, you see this black line. Because the hydrogen, that red light, did not go into your eyes. The hydrogen absorbed it and scattered it, absorbed it and scattered it. And if that light doesn't get to your eyes, you see black. But luckily, this is easy. It's the same thing. They're kind of like opposites, okay? Look, it's just like, black, color, black. But these lines match up. So scientists, if they're looking at the light being scattered, they see this. If they're looking at light being absorbed, they see this, but it's the same kind of fingerprint, okay? Absorption is like scatter in reverse. Scientists can look at the light created or the light absorbed as fingerprints of what atoms are present. So looking at this or this, you could look, you could determine, you could investigate what atom is in there. Now, one other way, so we've seen a couple different ways to look at fingerprints. Remember how we looked at the light from the sun? Remember, the sun is a type of star. And we had this graph. Look at the graph. It goes up and then down. And going up, that means more light, brighter, more light. We said that green light is created more than any other color, but more light, less light. Look at this, only a little tiny bit of light. Okay. And if you remember, we said that all stars like our sun, all of them have this kind of graph. They go up and then down. It looks like a hill. It goes up and then down. Remember, when you go up, that's more light. Now, this is a nice looking picture. But if you're a scientist, you can look at the sun and you can measure the type of light. This is not like a high school picture. This is real science data, a real science graph that an astronomer took. And look at this. They looked at a star, and here's that line. It goes up and it goes down. The same thing, up and then down. But look what's going on here. Go up and up and up. Oh, look, little dip. Or look over here. You go up and up and up, and bam, a big dive. Now remember, going up and down, that's a lot of light or a little light. What do you think it means if the graph goes down like this? It means right here at this wavelength, this type of light, there was absorption. Oh. And look right here, there was absorption again. Scientists often use graphs like this, and they can see the same type of absorption that we saw earlier. We could do it by looking at this, right? Absorption, absorption, absorption. There's very little light. No light, black. Or here, if there's little light, black, it dives down, less light. So this is another way astronomers, scientists can study absorption, can look at fingerprints. You could use a graph like this. Here we go, another one. Okay, when you see these dips, they're those same absorption lines. Interesting, interesting. That's actually the end of this video. We're still talking about fingerprints, but there's a couple different ways that scientists can look at fingerprints. Scatter, absorption, and also these absorption graphs. Interesting. Well, that's the end of the video. Thanks for watching.